All right, team. So this is going to be a breakdown of the formative from last Thursday to make sure that we have a better understanding for tomorrow's summative, okay? So the first part that we gave you, all right, we had a YouTube video for you to watch to understand neon signs a little bit better, and then we have a claim, okay? So the chemistry department of the University of Toledo, they wanted 3 different colors in their neon sign, okay? So we needed to figure out the elements that could make those colors, okay? So we provided you pictures of different gas tubes, all right? And the outline in white, we need half filled with red, and the words need to be in blue, okay? So we're looking at these gases, all right, and figuring out which 3 elements are we gonna need for this, all right? So looking at this, that's how I'm gonna draw my claim, okay? So if I look at this, the main one is going to be the red for my beaker, which is going to be made of neon, okay? The white is going to be made from krypton, and the blue is going to be made from xenon, okay? So I did that just by looking at it. For the most part, this was the information that we got correct. So I'm going to skim over this kind of quickly, but really just needed to make an observation of what colors would look best. Okay, some of you gave me argon. I understand that, but that is with some mercury. Xenon is going to give a better blue overall. All right, so if you had a valid reasoning, I didn't take off points for that, okay? Then we provided the photon energy and the wavelength and the speed, okay? So then, all right, on yours, these models, these rubrics are put underneath each section, okay? And we're going to look at that here in a second. But one of my biggest things, guys, and why I was most disappointed is that we didn't read the rubrics. Okay, we don't just type rubrics in for funsies, all right? There's a reason behind it. So a ton of you lost points on 2.1 by not reading the rubric, okay? You needed to show the Bohr model and the electron configuration for the 3 gases, all right? So please, please, please make sure that we are including that information, okay? So you were provided a outline that looked as such, okay? So for time's sake, I did fill some of the information in already, but we're gonna go over that here, okay? So the first thing that you had to do was make a claim, okay? So I made a claim to make the sign xenon should be used for the blue lettering, neon should be used for the red, and krypton for the white, okay? Most of us crushed at making a claim, but it's very easy to make a claim. It's a lot harder to provide the evidence for the claim, okay? So the evidence standard here is where we use 2.1, okay? So show the Bohr model and the electron configuration for 3 gases correctly, okay? So, my lovely humans, some of us gave me Bohr models, but we didn't actually show what was happening, okay? So I have attached I drew the Bohr model for krypton before this, okay? So I went on my periodic table, I looked at krypton, first ring holds 2 electrons, second ring holds 8, all right? And then when you go into the d orbital, you're gonna hold 18, 2 from the s, 10 from the d, and 6 from the p. Okay, so you could have given me a general Bohr model of krypton, but then you need to label it the ground state, okay? What I was specifically looking at, okay, was could you show the excitation of electrons falling back to their original states? Okay, so this should look really familiar from the POGL, the review, things like that, okay? So what I did here is I took 2 electrons. It doesn't really matter where you take them from. We're going to explain that in a second here with the 4, okay? So krypton gave off white light, which means it has multiple electrons falling, all right? So I showed 1 electron returning to its ground state at a farther distance, 1 on a shorter distance, and then I showed the white light being released, okay? So for your Bohr models, you need to label if it's in a ground state, you need to label if it's an excited state, and then remember, the whole reason that the color is being given off is that in the neon signs, they added electricity. When they added electricity, the excitation of electrons happened, okay? But that's not sustainable, so those electrons are gonna return back to their ground states. When they return to their ground states, that's when the light is given off, and that's how the different colors are given off, okay? So then I also included my electron configurations for krypton. I did 1 in the ground state, all right, so how krypton originally looks, and then I did 1 showing the excitation from a 4p to a 5s, okay? So I gave credit if you did it in the ground state. Only 2 people give me electron configurations, 2 or 3, right? Guys, the rubric literally says electron configuration. We're better than that, okay? So for a 4, you would have had to do the justification of the color choices, all right, and how the models relate to each other. So this is where the distance that you have your electrons fall would be more imperative, okay? So what I mean by that is if it's the neon, okay, neon produces red light, okay? Red light is the lowest energy. Okay, lowest energy, longest wavelength. All right, which means that when you would draw its Bohr model, its electron should be falling the shortest distance. All right. All right. So if you have any more questions about that, please let me know. Again, I don't really know if we understand how to do this section because unfortunately we didn't read the rubric. Please read the rubric. You're giving your teacher gray hair over here. All right. So if you have questions on that, let me know. So then the next part, and I did pre-type this, was the CER portion of specifically looking at the evidence, okay? So this is the area that we had the most effort, but not 100% the most understanding of what I expect out of evidence. So one area that we made a pretty common mistake. All right, and I understand how we did this. A lot of people thought that giving evidence was simply like telling me the relationship between the energy levels and what was produced. Okay, so I got a lot of information that said that like neon would have a photon energy between this and this and a wavelength between this and this, where krypton would have, xenon would have a wave energy between this, a wavelength between this and this, and a photon energy between this and this, okay? I'd love if you would bring in information from this table, okay, and explaining that krypton is white light, so it's all of the colors combined, all right? But here is the issue. That's not evidence as to why these different colors are specifically being produced, okay? That's part of the evidence, but that's not the full explanation of why they're giving off different colors of light, okay? So you did get some points if you said something like that, but you didn't get all of the points. So what I was specifically looking for, okay, is something along these lines, and I didn't put the wavelength energy in, because most of us did that, all right? So, but this is the main part that you needed in order to get that information that showed me that, hey, you understand the reasoning of why there's different colors being given off, okay? Then after this, you would include those energy levels that blue would produce an energy, a wavelength between this and this, resulting in this energy level or things like that, okay? But we needed to explain that the excitations of electrons by electricity in the sign resulted in them jumping from a ground state to an excited state. Okay, this is unsustainable, so the electrons would fall back to their original ground state, resulting in the release of energy in the form of colored light. Okay, they're going to give off those wavelengths. Okay, the difference in ground states and energy absorbed by electrons will result in varying wavelengths being produced for different elements. The different colors produced by the different elements corresponds with the energy being absorbed, neon absorbing the least and xenon absorbing the most. Okay, so I was looking for just the basis of understanding that we understood that when electrons get excited, they move when they fall back down, things like that, okay? And then explaining that neon would have the least amount of energy, moving the least distance, and then xenon would have more out of the three because it is blue. Okay, so krypton, of course, is white light. So that one is a bit different in regards to the fact that it is the reflection of all light. Okay, so if you have questions, please let me know. Otherwise, please make sure that you look over your formative. I've given feedback. Some of your files didn't attach. And on the summative, please submit them as PDFs, my lovely humans. Email me with any questions. Oh, also, 8.2 team is just about communication of information. Proofread your paragraphs, my lovely, lovely humans. You know when to capitalize things. You know when to add punctuations. You know not to leave random 15 spaces in between words. Come on. You're smarter than that. You're better than that. I know you all are. Okay. Email me if you got questions.